VS Series Area Tool. The Area tool converts the captured image into a black and white binary image and counts the number of black or white pixels present in the inspection region. Connect to the Area tool simulator and play through the images. The goal of this exercise is to detect the presence-absence of these defects on the target. In the inspection section of the step layout, add the Area tool from the presence-absence category. Set the inspection region to encompass the area of the target. Click the Region tab and add some masks to eliminate the areas that are not to be detected. So this center area here, and we need to mask out the corners around here. For the center area, add a rectangular mask. For these corner areas, add 2 arc mask regions. Go to the Image Enhance tab to adjust the binary filter of the Area tool. You can adjust the upper and lower limit range of the binary conversion. All pixels between the upper and lower limit will be converted to white or 255. All the pixels outside this range will be converted to 0 or black. You can see in this example, it is difficult to extract all of these defects under the current conditions. So if I adjust this binary level, you'll see that it's difficult to extract out just the defects without the background. So since this is a color camera, we can go into the extraction method settings and change how this image is converted to gray. As a default with the color cameras, for the grayscale tools, the image will be converted to grayscale using RGB grayscale, which basically takes the average of the red, green, and blue intensity values of each pixel. So in this example, what we'll do is we'll change it to color to grayscale so we can pick the color that stands out, basically. So if you click the pick button here, it will allow you to pick a color. So click on this yellow-ish background of the target, and we can make that be 255 or white, and then all these similar shades of color become shades of gray. So the background color of the target stands out. Now, since the background color of the target is really bright, we can easily adjust the binary level, upper and lower, to detect all the targets here that are darker than the background. Go to the detection settings and you can set whether to count the white or black pixels. So the Area tool, as a default, will count the number of white pixels that are present, as you can see here in the results, or you can change it to detect black. So let's change this to black. So we'll count the number of black pixels. And in our good target, image number 1, we should get a really low value or 0. You could adjust the regions as needed. We're probably picking up a little bit of pixels on the top there, maybe on the bottom. But you can adjust the regions as needed to just bring this one in here. So you can see, if I bring this one in, we are now getting 0. But you can adjust the regions as needed. So we get a very high pixel count when we have the bad target, so it's counting the number of black pixels, and then we get a really low count, i.e. 0, when we have the good target. So you can adjust the region as needed to fine-tune that in, but we can go to the judgments now and set our pass-fail judgment. So our good target is not supposed to have those features, we can put an upper limit of 0 or whatever the number is. So if the value goes above this, the tool will fail. So you can see now our count has gone above the upper limit of 0, so the tool is failing, and it passes when it doesn't exceed the upper limit, i.e. 0 in this case. Now, if it's the opposite condition where maybe you want presence of these features is okay and missing features is no good, what you can do is simply put a lower limit of, in this example, let's say 100. So when the parts are not present, the value drops below the lower limit and fails. And when they're present, it goes above the lower limit and passes. So you can adjust the limits as needed for the application. So in summary, the area tool is a good presence absence tool to count the number of black or white pixels in the inspection region.